example, let's see. Yeah, sure. Like number 29, Nina is waiting in line at the DMV. Her wait time of 32 minutes is the 85th percentile of wait times. Let's see if I can get this there. There we go. Cool. My hand. Is that good or bad? If her wait time of 32 minutes is in the 85th percentile. So what does that mean directly?
85% of people waited less time.
85% of people waited less time. I love it. So is a high percentile always bad? No, it depends on the situation, right? So this whole list of problems here are all just about, here's the situation. Is this high or low percentile good or bad? Right? That's pretty straightforward. No math, just straight up explaining, just thinking about what percentiles mean, right? Is that cool? And by the way, statistics is a prime example of a math class where there are several problems that involve no math. It's just the reasoning. It's just the ideas, right? Then you have a problem like a classic problem like, number 23. So if I wanted to figure out the 78th percentile, what would be my first step? How do percentiles work? I want to know the 78th percentile. No? Oh, I see what you're doing, but not quite. 78th percentile is more specific.
78 times 29?
Yeah, right? You would take 78% of 20. I want this to make all the sense in the world if the freaking data is in order. Where's the number that has about 78% below it? Well, I would go 78% of the way into the list. Didn't I just pass by 78% of the data, right? So of course the first step would be 78% of how many freaking numbers there are, right? No, that's going to be a decimal. You guys agree with me? 0.78 times 29 is going to be a freaking decimal. So if I get a decimal, what do I do with that number? Round it up, no matter what, and go take that number, right? So if I did it and I got 11.2, 12th number is the answer. You just always push that thing up, right? If I do the percentile and I get 7, what does that mean?
Average.
Yeah, you take the 7th and the 8th numbers and average them, right? So the first step on any percentile problem is basically where is the answer, and the second step is go get the freaking answer, right? Is that cool? So percentiles are not that bad. They're just different from what we're used to, but they're really not that bad. They're just this percentage is below this data point. So that's why the steps make sense. I want to pass that much of the data to get about where the answer is going to be. There's just that two things, that the adjustment we have to make. We either average it or we round it up and take that number, right? Okay. Let's do this real quick. Let me add a part C onto this. How would you find Q1? What does Q1 mean? 25th percentile, right? The first quarter. So what would be your first step?
Divided by 29.
No. So if I want Q1, that's the same thing as P25. So the first step of any percentile is to take that percentage of the number. So in this case, 29. So I take 25% of 29. What is that? 7 point. So 7.25? I'll go with that. So what does that mean? What do I do with that?
Round it up.
Round it up. So this whole first step is, where is the answer? The answer ain't 8. The answer is the 8th number, right? And then you just go in, 2, 3, 4, 5, 6, 7, 8. So it'd be 30. So 30 is roughly the number that has 25% of the data below it. Okay. Does that make sense? So the math of it is pretty straightforward. Every percentile always means the exact same thing. That percentage is below the data point. So if we're talking about SAT scores, you want a high percentile. If we're talking about golf scores, you want a low percentile, right? That means you're doing better. Let me think. Blah, 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 blah. Yeah. Okay. Okay. And then, 26 is sort of like the other ones we just talked about. Just can you figure out in this context what's a good percentile, what's bad, what does it mean? Those kind of things. If you're a 20th percentile for run times, right? So you ran a race and you finished in 5.2 minutes and you're in the 20th percentile. Is that relatively good or bad? Because what does 20th percentile mean? You finished in 5.2 minutes. What does the 20th percentile mean? 20% of what did what? 20% of people took less time to finish. So what percentage of the people took more time to finish?
Like
80%. So relatively, is 20th percentile pretty good for race time? Yeah. Right now, depends on, you're like, I want to be top 5%, but it's a hell of a lot better than 30, 40, 50, 60, 70, right? You guys kind of see what I'm saying?
Yes.
Okay. Now, if we talk about speed, your speed in a race. So time, you want to be a low percentile. What about speed? You want more people running faster than you or less people running? So would you rather have a high percentile for speed in a race?
Yeah.
So if you were in the 80th percentile in speed,
80%
80% of
of people.
people were
So easy.
always less. Percentiles are so single-minded. They're just always, whatever this number is, this percentage is less. So 80% of people had a speed lower than you. Is that good or bad?
Good.
Good. Yeah. Only 20% of people were faster than you, right? Okay. Hopefully that helps. Anything else from homework stuff? So remember box plots, for example, were in section 2.4. That's why they weren't on the quiz today. Box plots. Right? And what do you have to figure out to be able to make a box plot? What do you have to first figure out?
The 5.
The 5-number summary. I love it. Okay. Maybe. All right. So let's see. Any other questions from any homework stuff? Where should you be right now in homework? Well,
2.4.
yeah, I'd say if you're at least in section 2.4, you're in a good spot. If you're still doing section 2.1 homework, you got some time. You got until the day of the test to really get all the practice in, but you're a little behind, right? So you got to catch up.
Yeah, I already finished the first 2 sections of it,
Okay.
and I'm still stuck on like
The 2.3.
Yeah.
Yeah.
Is that fine? Or is
Yeah, you're in a decent spot.
balanced?
Yeah, you're in a decent spot. Okay. So nothing else, you guys? All right. So I appreciate you are here today, but if you're behind in homework, if some things are not making sense, you need to come get help. You need to come see me. You need to see some tutors, right? And I try to make myself really available. And if nothing I offer works, if you're like, dude, I got practice, I got jobs, I got all this shit, every time you say you're available, I can't meet with you. Just shoot me an email and say, these are the times I could meet with you. Because do you guys understand I'm in my office a little more often than I tell you? Why would that be?
Because you're gonna put the minimum there.
No, because I need time to do shit, right? So there are times that I am here on campus, but I haven't put them on my office hours because I got stuff I got to do. But if you send me some times you're available, if none of the times I offer work, I will find some time to meet with you. Right? So like on the syllabus, they say other times by appointment. Right? Okay, maybe. Okay. So let's do this. If there's no other questions from homework, I want to jump right back into where we left off from section 2.7, which is all about standard deviation. And I gave you the example of teachers, comparing two teachers, right? We talked about that crazy ass website, Rate My Professor, for example, right? And there's that other website. Did anyone even look for it? The one that tells you like grade distributions of teachers. They tell you how many A's, B's, C's, D's, whatever. Okay. Got to pay for that one, but we talked about if you knew two teachers gave an average of a C, if you also knew how spread out the grades were that they gave, that would help you make decisions, right? So that's why, in general, given a data set, given data, we very often calculate the mean and the standard deviation immediately, if it's numerical data, right? So we get the mean and the standard deviation. Now real quick, can somebody remind me, the symbols I've just written, they're obviously Greek. What does that mean? What do they both describe? Versus this and this.
Both.
Yeah.
They're both describing a population.
These are describing population, so they're parameters. And these are describing a sample, so they're both statistics. Okay. So that's what they mean when they say don't become a statistic, because almost every data set we have is a sample of something, right? Okay, so let's remember some formulas. Does somebody remember the formula, the official formula for the mean? Yeah, good. Greek letter sigma. And what does that mean, that symbol? What does it tell you to do?
Sum up.
Add them up, that's all it means. And in this case, given a set of data, a bunch of x values, what would I do to figure out the mean? I would add up
Sum of x.
all the data values, divided by how many there are. I love it, right? Now real quick, this would give me the average x value. Is that cool? Right? So what if I had two sets of data, like I have my morning class grades, blah, 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 and my evening class grades, blah, 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 right? What would this mean?
Average y.
The average y value is crazy. Holy shit, right? And if I wanted to, I could say these are for the x's and these are for the y's. So you'll see that in your calculator in one specific place. How are you guys doing so far? Not too bad, right? So anytime I see, let's take this away. Anytime I see the sum of something divided by n, that is an average this. Okay, so if I added up shoe sizes and divided by how many there are, it's the average shoe size, blah, 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 right? Okay, so last time we created a freaking equation, right? Normally in mathematics, we give you the equation, you just work with it. Last time we made a freaking equation. And let me remind you what that was. So what we did was, let me do this. Yeah, I'll do this. Okay. We added up a bunch of somethings. We added up a bunch of distances from the mean. So we took every data point and we saw how far away from the mean it was. Right? So the idea of standard deviation is spread of data. I desperately, so for statistics to work the best, you have to understand the idea behind each formula. So you use them in the right place. So that's not done yet, right? So last time we wanted to figure out the spread of the data. So what makes sense for the definition of a spread? how far does the data get away from the middle on average, right? If on average the data gets 1 away from the mean, that means it's really tight, right? So let's say the mean was 70, and if on average all the data points get 1 away from the mean, that means it would be pretty tight to the mean. Nothing gets too far away. On average, they get 1 step away. That would mean they'd have to be really close. Maybe there's some 70.5s, 69.7. I mean, they'd have to be really tight to the mean because the standard deviation is 1. They don't get very far away from the middle. So that could be like a standard deviation of 1. If the standard deviation was 20 and the mean is 70, on average, they're 20 steps away. So maybe there is something close, but then there has to be something pretty far away. So on average, they get really far away. They get 20 away. Does that make sense? If I want to know how spread out data is, and I have this idea of the middle of the data, one way to describe spread would be, well, how far does the data get away from its middle? Right? How far away does it get on average? So that's why I took how far away did each data point get, and then I wanted to add them. Now the problem with that was the answer came out to be frickin' 0 every time. I don't know if you guys remember. We'll do another example. So I had to square it, and that's why there's this big ass square root. So what does this do? I see the sum of something over n. So this is the average squared distance from the mean. So when I square root it, I get the average distance from the mean. Okay. So let me show you how to do this work, how to set it up and do some of it in the calculator, which would be nice, right? The calculator costs enough money. It better do some stuff for us. Put this over here. Okay. So if I have some data, let me make up some data. What do you got, Jeff? Let's see if I can make this nice. 14, 25, 37, 37, let me see. Yeah, let's do one more. Yeah. Yeah, okay, there, add one more data. Just trying to make this come out nice for the moment. Can somebody really quickly, everybody, 3, 4, 7, 11, 12, 17. Can somebody calculate the average for me real quick? What's the average? We'll see, this is a population for right now. Right? Because when you add these up, you get, what is that, 54? So the mean, you do that over here. The mean will be the sum of x divided by n. It's 54 divided by 6. So the mean is 9. Cool. Now, looking at the data real quick, just looking at it. Like 3 is 6 away from 9, 4 is 5 away from 9, 12 is 3 above 9, 17 is 8 above 9. So standard deviation is going to be somewhere within 0 to 10 or so. I'm not going to expect the standard deviation to be 20, right? Nobody gets 20 away from the middle, do they? So there's no way the average distance is going to be freaking 20. So I would guess that the standard deviation is going to come out to be like 7 or something, or probably less than that, like, because there's a few that are really close. So like 4 or something, I don't know. So if the standard deviation is supposed to measure how far from the middle do all the data points get on average, then it should be obvious I've got to calculate how far away does each one get. So we just described it. What's 3 minus 9? Negative 6. 4 minus 9? 7 minus 9? 11 minus 9? 2. 12 minus 9? 3. 17 minus 9? 8. Now real quick, can you verify for me, if you add those together right now, what do you get? Freaking 0. All right, that's bullshit. And that will happen every damn time. So of course I'm not just going to take this, because then my standard deviation is always 0. Does it tell me anything then? No. So I already talked about the fact we don't want to use absolute values. There's good math. There's many mathematical reasons why we don't. There is a statistical idea of standard error, which uses the absolute value, but that's not used as often. So what we do instead, to make them all positive, we square them. Yes?
Should we be worried that we made a mistake if it doesn't add up to 0?
If you had to round something, like let's say the mean came out to be 9.0257639, blah, 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 right? You're not going to use that whole damn thing. So if you round something, this could come out to be, but it should be like 0.2 or negative 0.17 or something. It should be really close to 0. But it could be because you rounded, just like a frequency table not adding to 100% because of rounding. Same idea. Does that make sense? So, but it should be close to 0. If you get like negative 5, you made a mistake, right? Okay. I really want you guys to get the idea, because, again, to get the average anything, I need a list of them so I can add them and divide by how many there are. Yes? And we want the average distance from the mean. So let me get a list of different distances from the mean. Now we got to do this weird shit because they're negative and they kind of cancel each other out. That's bad. So we square them and then square root them at the end. But it's still the same idea. So what do we get here? 36, 25, 4, 9, 64. So see what the formula needs. It needs a bunch of these. Well, we got them. And then it needs the sum of those. And I'm going to show you in a minute how to get all this on the calculator. So we're going to get 40, 69, 78. Is that 142? Yes? Okay. By the way, what did I just do to get 142? I added, so that's add. What did I add? This. All of these, right? Become a minus. Dadgummit. So this whole freaking thing is 142. We are so not used to this from algebra. In algebra, we're so used to plugging stuff into A and X and Z and Y. But I know what the hell this whole freaking thing is. Anywhere I see this, I can put a 142. So of course, I see it right there. And what's N? Yeah, and there were 6. It's like 4.83, just to make something up.
6 times 4 is 142.
No, square root though.
Oh, I thought you were
There you
trying
go.
to do that first.
No, I'm trying to get the whole damn thing.
Absolutely not. I have no idea.
No worries.
I'm going to say 4.4.
Is anybody able to get that? You guys all have calculators, right?
4.8.
4.86.
Ooh, you're closer. 4 point, and keep going. 4.8.
6, 4, 8, 3.
So like that. So here's the big thing, okay? This is a major note. Standard deviation, you always go at least 3 decimal places, always. So in standard deviation, we always go at least 3 decimal places. I like it. So again, It's the average distance that the data points get away from this. So 11 is only 2 away, 7 is only 2 away, but 4 is 5 away. So on average, they get about 4.865 away. That's an estimate of what that distance is, that average distance. Does that make sense? So, real quick, what I want you guys to do, well, let's see. Let me just ask you this. If I were to change, let me see if I can do this real quick. If I were to take this data instead, in fact, let's do this on the calculator. If I were to make this 3, 6, 7, 9, 12, 17. Right, do you see that? I made that 6, and then I made that 9. Right? Do you guys understand that? Let's see if you guys understand. Didn't I make that go up by 2? I made that go down by 2, yes? So isn't it going to be adding to be the same thing? So the average is still 9? Without doing any work, can you guys tell me, will the standard deviation be higher or lower now?
Lower.
Why?
I feel like my numbers are a lot closer together.
Good, beautiful, right? 4 used to be 5 away from 9. Now I made it 6. That's only 3 away from 9. I made this one frickin' 9. That's 0 away from 9, right? So that's exactly the right idea. I made the middle kind of get closer. So let's do this data. Let me show you how to do all this shit we just did in the calculator. Right?
Should we put the new information on our?
Yes. Let me see. We do it on this, I think. Blah, blah, blah. There you are. Okay, so let me go to my stat edit. If you got stuff in the list, then you just go up to list 1 and hit clear. Don't hit delete, because it'll actually just make the list die. So let's put in there 3, 6, 7, 9, 12, thank you. I like it. Now what I'm going to do is I want the second list. I want list, so this is list 1. I put all the X's into list 1. I want list 2 to be this. See again? I'm sorry. There's a lot of stuff going on. So here's the first one we did together. Here's the one we're doing right now. I want list 2 to be the X minus the mean. And of course, the mean we already figured out is 9. So look what I could do. If I go up to L2, just go up and highlight L2, it's waiting for me to tell it what the hell L2 is. I want L2 to be each X minus the mean. Where are the X's? L1. So I want, see above 1 where it says L1. I want L2 to be L1 minus the mean. I know, it's mind blowing. So again, this calculator costs enough money, you should be able to do something like this. So what do I want L3 to be?
That square.
I want that square, and of course, that being L2. So I go up to highlight L3, and I can tell it, make the whole freaking list L2 square. All right, so let me know if you have any issues. Everybody who's trying to play along, are you doing okay?
How did you do that? L2 again?
Let me see. Oh yeah, so go up to L2, so hit the up arrow. Good, so now you can control.
What happened?
Oh, what?
Not erase his number because it was
Hit
there.
clear.
I tried.
Oh, hit delete.
Oh. No.
Hit enter. Yeah. What is that? Clear, enter.
Okay.
Oh, or just overwrite it. Yeah.
Oh.
3. There you go.
Oh, thank you, thank you.
Okay, so now tell it you want X's minus the mean. So tell it L1, so you have to hit second 1, minus 9, because we calculated the mean is 9. Enter. Now go over to L3, and you want it to square all the stuff in L2. So you want it to be L2 squared.
L2 on here?
Say again? Go up to L2.
Oh, L2, yeah.
Go up to L2.
Yeah, I'm ready.
No, no. Oh, there we go. See, now you can tell it with the whole list. So it's second L1 for L1.
Okay, so we click second.
Yep.
And 1
Minus the mean, which is 9.
minus 9.
Yep.
Okay,
And
and enter.
Yep.
Okay, great.
Good man. And now go to L3 and you want it to be L2 squared.
Okay, so
Of course, L2 is above 2. That would be helpful, Jeff. So let me do it one more time real quick. Alright, so one thing, watch this real quick. If you ever get this error, I'm going to do L1 minus 9, and it's going to give me an error. This data type error is basically it's saying, dude, you can't shove a whole freaking list into one spot because I went to the wrong place. Look where I am. I'm trying to put a whole list in this one spot. It's like, no, go up to L2. Now I can tell it, I want this whole list to be L1 minus 9. Now it's okay, right? Then I want the next one to square those. Why am I squaring them? To kill the negatives. Because otherwise they all add up to be 0. So I want this one to be L2 squared. And again, we're just doing the exact same stuff we did here. We're just doing it, instead of by hand, we're doing it in the calculator. Now, what do I want to do with L3? What did we do with this? Well, I want to add them all up so I can throw that number right there, right? So in the calculator, and again, this is not a very big list of data. That's pretty simple to do. Let me just show you how to get the calculator to do it for us. If you want to try this, hit second mode to quit. You got to come out of your table. Do you see above stat where it says list? I want to do something with my third list, right? I want to add it up. So I want to do some math to my third list. I want to sum. Right there, I want to sum my list 3. So what we just did is equivalent to what we did here, right? And then I can just throw that number into the formula, 122, right? Because now this is 122 over, it's still 6 data points. Yep. I love it. Bam. All right. So why does it make sense? We got 4865 here, and we got 4509 there. What was it about these why that makes sense? Those two numbers, these two data sets. Which one is more spread out? Which one gets away from its mean more? The first one, right? In fact, this new set of data had a data point that was exactly the mean. So it got away from its middle. So the number that represents how spread out the data is for the middle should be bigger for this one, because it gets away from its middle more. So it's a very quick number to calculate that out. Just give me the idea for the whole data set. Now, this is not a very big data set. But if I had 1,000 numbers, I don't want to see all 1,000 numbers. Just give me 2 numbers, the middle and how spread out it gets. Right? That'll give me a really good idea of what's going on. So if I gave a test to one class, let me take some of this away. If I gave a test to one class, and their average score was a 75. This is class 1. And I gave the same test to class 2, and their average was a 75. But these guys' spread was 20, and these guys' spread was 4. What does that tell me as a teacher? What does it tell you?
That's what it was.
Say again?
That's when I had a different test with it.
Oh no, the same exact test. Just 2 different classes, right? Like a morning class, evening class.
Class 1 girl.
Which one had people that did really well?
Class 2.
Plus 1.
Class 1. Because what's 20 up from 75? 95. So on average, now which class had people that did really bad? Class 1, right? Real quick. So these guys only got 4 away from the middle on average. So maybe there was somebody who got a 90, right? But then there must have been a lot more that got closer. So on average, they only got 4 away from 75. So maybe there were no A's and there were no F's. There were just a bunch of B's, C's, and D's, right? And this one, there were people that got really low F's, but then there must have been people that got pretty good A's at the same time. That's why it was 20. It's so spread out from the middle. Do you guys get the idea? Maybe. What about visually? What if I give you this data set versus this data set? Which one's more spread out? Which one would have a standard deviation that's bigger? Which one is more spread out? Second one, isn't it more spread out? Isn't there a lot more shit close to the mean in this one? Whereas this one, a lot more gets further away from the mean? Maybe? Right? Or I can go really extreme and go like that. Wah! Now, like almost everybody is really tight to the mean then. That would have a very small standard deviation. That would have a regular size standard. This would be a big ass standard deviation. It's really spread out. Okay, maybe. Now, on a test or a quiz, I am going to need to see this table created. I'm going to need to see this formula used. Is everybody with me? I will now show you the ultimate shortcut. We're going to hit a few buttons and get this freaking number. Yes? So that you can check your work. Making the calculator do it is not work. So let's try this. Oh, well then I missed all that. That's okay. Someday I'll remember to turn the camera. So if you go to stat, we already did this once where we got the 5-number summary. Go to calc and do 1-var stats. Right? Let me do it again. Stat, calc. I want to calculate down something. I want to do 1 variable statistics. Because I only have 1 list of data. And either it's going to say 1-var stats on your screen if you have an older calculator, and then you just hit enter, or it's going to have this stuff so you get down to calculate, make sure it's list 1. Let's see what we all got. Now the calculator is stupid. It doesn't know shit. So is it using the right symbol here? No, because it was a population, but it doesn't know. It just tells me the numbers you gave me, their average is 9. Look right here. There's 2 separate things here. That was a population, right? So which one am I going to use? Sigma. So you got to be really careful. Calculator, again, doesn't know. It's just going to give us both. We're the humans. We have to know which one to use. So of course we got 4.509. Thankfully the calculator got 4.509. Yes? So this is a great way to check your work. Yeah.
How does it get the other number?
Well, I showed you last time, but let's do it again. So all the work we did just now was for a population, correct? I said it was a population, the data that it gave us. At the end of last class, I kind of quickly went over an adjustment you have to make if it's not a population. Let me erase all this.
Oh, yeah.
Yeah. And let me all right. Let me remind you what it was, and then let me go take a little deeper dive into where this thing comes from. So here is for a population. Yes? Population is the one we just used. For a sample, and this is the thing where I did last time where I said if I took you guys and I took your average age, you would be closer to the average age of the sample versus the average age of everybody. Of course you would. Maybe? You guys get that? So if I just took 2 people and I took your average age, you each would be closer to that average age than you would be to the whole average age of everybody, more than likely. So what does that mean? If it's closer to the average, that means the standard deviation would look like it's smaller than it's supposed to be. So how do I make a number bigger? Well, one way to make a number bigger is to divide by less. If I divide by less, doesn't the result become bigger? Yes? You guys with me? What's 20 divided by 5? 4. What's 20 divided by 4? 5. Holy shit, the answer became bigger because I divided by less. And the only other difference would be right there. Instead of mu, what would I use for a sample?
X bar.
X bar. They are essentially the same formula. This little guy is just an adjustment because it's a poor little sample. And by the way, let me make sure you understand, I don't know if I said this on the syllabus, I might have, but for the test, you will be allowed to have a formula sheet. There can be no words on the formula sheet besides maybe the words formula sheet. Yes? Do you guys understand? So I will let you have a formula sheet. We will actually create it on the day of the review. We will create the formula sheet together. And you can bring it with you to class for the test. You're going to turn it in with a test, and if there's anything illegal on it, you're going to lose points for that. So you can only have the formulas. Okay. So real quick, a little word about this n-1 thing. Where the shit did that come from? Let me ask you this. Look. If I have, we sort of talked about this before. If I have 3 numbers that average to be 10, do you know anything about any of the individual numbers? I have 3 numbers that average to be 10. But I don't know, I have no idea what any of them, do any of them have to be 10? No. But I do know one thing. What do I know? If they average to be 10, they have to add to be 30. Does that make sense? Because if I'm going to average 3 numbers, I add them up, divide by how many there are. What do I divide by 3 to get 10? 30. So how many numbers can I just make up?
2.
So yeah, give me a number for the first one. 12? Cool. Somebody else give me a number for the second one. 15, sweet. What did we just say that the sum, can I just make up a number for the third one and have it average to be 10?
Yeah.
Can I just make it anything I want it to be?
Oh, no.
What does it have to be?
Has to be what adds up to 30.
Yeah, so far I got 27.
Yeah.
So this has to be 3. So how much freedom, if I have 3 data points, how many of them can I just make up? 2, n-1 of them. Maybe. So, with a sample, we assume the one data point we don't know is the one that would make the mean the same as the population mean. So effectively I'm saying I have 1 less data point than I need. That's why we divide by n-1. Because there's 1 data point we don't know. It's the one that would be the perfect one, the one that would make the means match up. Now if you really didn't get what I just explained, you can fall back to this is just an adjustment because it's just a poor little sample. So for the sample, we give it a little adjustment. This is for a population. If I have a sample, I have to adjust it a little bit. And again, Greek letter for population, our letter for sample, that happens not all the time, but often enough.
Can you do like for that n-1? Is it just like previous like 9 or something like that? You like do 9 minus 1?
Yeah, so like the last one we did, we had 6.
Yeah.
We would just divide by 5 instead.
Okay.
Yeah.
Got it.
Awesome. So, let me see. You guys all got this one last time. Tell me if you need this handout. Let me change that. The standard deviation handout I gave out. Let's see. This guy. Does anyone need this? Yes. So on one side of this, I have a fully worked out example. So you can have this while you're doing your homework. And whatever, that was good. There. I also have some extra little questions down here, so you can reference that. So what I want you guys to do is to do the back. And look what I have done for you. I have told you exactly how to do this. Okay. Right, so you can use your calculators to kind of fill this in quickly, right? So go ahead, give this a try, put that in the calculator. You don't have to sort, but it's not a bad idea to sort. It doesn't matter if you do or don't. But I would recommend that you do sort, so put that in. This will be a good review on just handling data. Right, so go ahead and put that data in. All right, guys, I'm going to sort of slowly start to catch up to you. So try to be really helpful here. This is exactly what you want L2 to be is L1 minus 6.5. Of course, the glare doesn't help. So if you added up L2, it should be close to what? Or in this case, it'll be exactly what? 0. We didn't round at all, so it'll be exactly 0. I want L3, so that's a problem. So I want L3 to be L2 squared. And again, that explains why we square root at the end. Yeah.
How do you add up the one listing?
Oh, yeah. Let me show you. Those numbers look like what you guys are getting? I don't know if you sorted yours. I sorted mine. It just makes it easier to keep track. So now I need to sum this list up, right? So I first need to get the hell out of the list. Let me go to second mode and quit. So now I'm going to go to list. I want to do something to my third list. So go to list. I want to do some math. I want to sum up my third list. Sum up L3. And of course, all the lists are above the numbers. There we go. So this adds up to 69, and then you can put that in the old formula. Let me stop for a minute. Is that cool? Because we're in stats. I know if you had to, you can multiply shit out and add stuff up. Might as well make the calculator do all that calculation stuff, but I need to see the formulas get used. So what am I going to put up here?
69 over
5.5.
No, careful. N minus 1. What's N always? N is always, no, N is always the number of data points. It'll be 12 minus 1, right? Now this is something I haven't said yet for some reason, but before you take a square root, it's what we call the variance. The word kind of makes sense. It's how much the data varies, right? So what do you guys get for that?
6.27.
Yeah, 6.27 like forever, right?
Yeah.
So let me show you the calculator. So I got that. Then I need to square root that. Do you guys remember how to do that? You hit square root of the answer, right? The answer button.
Okay. Is it right?
So then I get 2.505. If I round up, you see that? So on average, the data points get roughly 2.5 away from the mean. How do I check that real quick in the calculator? What do I push to check it?
You go to the list.
No? Go to stat. Calc. One of our stats. And of course, this time we need S, right? Because this is a sample of grades. So we need S. And sure enough, 2.505 is the same thing. Yeah. So some of you guys, one semester I had a kid that said, hey, you make me do all the work. My last teacher didn't make us do that bad. You don't have your last teacher anymore. You got me. You got crazy ass me. But at least I show you how to check your work. But I gotta see your work. I want you to be connected to these formulas and what they mean. Okay. Now, let me see this. I got so little time. Let's say, little side note, little conceptual thing. Let's say you're in a class and the average on a test is a 70, right? And you scored an 80. You with me? That's above average, correct? But what if the standard deviation, the average is 70, what if the standard deviation was 20?
Then you're half of one away.
Yeah, you didn't even get a full standard deviation up above the mean. You're half a step up. So if the average was 70 and the standard deviation is 20 and you're at 80, you're only half of a step up from the mean. You guys semi with me? Now, if the standard deviation instead had been 5, then you're actually 2 steps above the mean, right? 2 steps above the mean. Okay, maybe. So this is a relatively better score than this, even though they're both 80. You guys kind of follow what I'm saying? In which case is there more of a chance that more people got A's? First one. So you got an 80 and there's a lot of people that got A's. So relatively you did worse. Over here, the standard deviation is 5. On average, they only get 5 steps away. So then 80 is a relatively good, it's a relatively high score. So that's why it's important to know what the standard deviation is. In fact, what I just did is sort of like what part C is about. If somebody made an 8 on the quiz, they scored above average, correct? Because the average was 6.5. But saying above average now, for us, is not good enough. Relatively, how far above average did they do? So what I do is, I'll say, okay, they scored 8. If I subtract 6.5, that's how far above the average they were. But I want to know relative to how spread out the data points were. So divided by the standard deviation. This gives me an idea of how relatively good did they do. So what is that? What is 8 minus 6.5 divided by 25? 25 is 3/5 is 0.6 roughly. Sorry.
I said 0.599.
Is it?
Yeah, if you round, it's like 5.989. Something say 0.6.
So 0.5989 something?
Yeah,
What you're saying?
just 99.
599, so about 0.6. You can do it, Jeff. There you go, buddy. So they're about 0.6 of a step above the average. Yes.
Do you want us to round that to the tenths? Just like always?
In general, we're going to round to 2 decimal places.
Okay.
But if we do that here, it still goes to 0.60, right? And you'll see why later this semester we're going to have a chart with a bunch of these things on it, and they're going to have 2 decimal places on it. So in general, I want to round these to 2 decimal places. This is what's called the z-score. So let me see if this makes sense. So again, if in this situation, How do I know there's 2 standard deviations from 70 to 80? How did we know that?
The standard is 5.
Yeah, so how far apart? It's 10 apart, divided by 5, there's 2 steps, 2 standard deviations. So isn't that exactly what this formula says?
Yeah.
How far do I have to go divided by how big each step is tells me how many steps. So it's not even a full step up. So it is above average, but not even a full step up above average. You guys get a feel for what that kind of means? So I like to think of, when I calculate a standard deviation, it kind of sets up tick marks on a ruler. The z-score is me laying the ruler down and measuring. Are you kind of with me? So like if I want to measure how far apart 2 of you guys were from each other, would I use miles? No, because the average distance from people are from each other in this room is based in feet. So standard deviation is sort of like, okay, what makes sense in terms of how spread out the data is to use? We're going to use 2.5 for a step. If I had really spread out data, I'd want to use maybe 25 for a step. Okay, maybe. So I will sometimes call standard deviation step. But be careful, if I'm asking a conceptual question on the test, don't say step, say standard deviation, right? And then this last problem, and again, you have a whole worked out problem on the back you can reference to kind of help you out. But let's try to just follow the instructions here. Put the mean in the middle. If I add 1 standard deviation up, what is that?
9005.
So if I add 2.505, I'll get up to 9 points. Get in there. 0.05 thing. And if I subtract a standard deviation,
3995.
what'll it be? Yeah, 3995. Let me stop for a second. So if I go 1 step up, 1 step down, how many data points did we just catch? What's in between? How many data points? How many data points are between 4 and 9?
Almost
12?
All of them? No.
Oh.
all but 3 of them.
Yeah. It's not the 2, and it's not the 2 10s. So there's 3 of them that are outside of there, right? 2 is out here, and the 10s are up there. So how many is in here? 9 of them. What percentage of the data points is that? There's how many data points? 9 out of 12.
Which is
And that, of course, is
75.
75%. Now, this idea of how many data points are within 1 standard deviation, that's a huge idea. So I want to do a concrete example of that right there. All right. Dadgummit. I am out of time. I am more than out of time. So next time I'm going to have the quizzes graded. Remember, yeah, that's right. Next time I have the quizzes graded, I'll have the answer key for the practice test. The test was moved to the 23rd, right? You guys remember it's going to be a week from today. And I'll post the video from today up later today. Yeah, good, yeah. Give me any homework you got.
Only once